Okay, so now, recall in previous videos, recall that a solution to an equation, okay, are any of the numbers, what we call roots, are any number or numbers that make the equation true. Okay, so that's what we call solution. So the quadratic equation, the solutions or roots to the quadratic equation are any of the numbers, okay, that when we plug them into the equation give us a true statement. Okay, so that's what we're going by. Okay, now for quadratic equations there are two roots. Okay, so unlike with linear equations where there's only one root, there's only one solution, in a quadratic there are two solutions. Now those solutions may be distinct, they may be different, okay, or they may be the same, which means we have a double solution. So in other words, we only have one number that is a solution. Or they could be imaginary, okay? So at this point, we're not going to solve for imaginary numbers, but just understand that, hey, we could have an imaginary solution, okay, or imaginary roots. Okay, so now, let's take a look at these three examples here, these three quadratic equations on the board. Okay, now the first one has two roots, 1/3 and 2. Okay? Okay, or you could just write it as like that, but they have two roots, 1/3 and 2. Now, you do this by factoring this, right? And if you factor this, then you can get the two roots, the two solutions, okay? Now, to show that these are solutions, all you have to do is just plug in the x values to verify that you get a true solution. So if I put in 3 and 1/3 minus 7 times 1/3 plus 2 equals 0. Now this side should equal 0, right? So I should get -2 here plus 2. So here I get 1, right? 3 times 1/3 is 1 minus 7 times 1/3 is what? 7 1/3, which is also 2 1/3 plus 2 equals 0. Now the left side, oh, I forgot to square this. Forgot my square. So that's not going to be, this is going to be 3 1/9. There we go. Okay. So now, so all I did was plug in 1/3. Okay, now I've got this. Now 3 1/9 gives me what? 3/9, which is 1/3. Okay, so then I get 1/3 minus 2 1/3, which gives me -2. -2 plus 2 equals 0. So it works. Okay, and you can do the same thing for 2. Just plug 2 in here. You'll get 3 times 4, which is 12, minus 7 times 2, which is 14. So 12 minus 14 is -2. -2 plus 2 is 0, and it works. Okay. Now what about this one? B. B has a double root. Okay. So in this case, both of the roots are the same. X equals 1/2. Okay? And again, to show that it's a root, all we have to do is plug in a half into x. So this should add up to -1, right, to counter off this +1. So this is going to be 4 times the fourth. And this is 1/2 of 4, which is 2. And so 4 times the fourth is 1. 1 minus 2 is -1. -1 plus 1 is 0. And we're done. Now, what about C? Now, C does not have a real root, okay? It has an imaginary root. And in this case, the imaginary root is plus or minus the square root of -3. And so you can see this by just solving this for x, right? So if we get x squared equals -9, right? We just subtract 9 from both sides. And we take the square root of both sides and we get x equals. And remember, when you take the square root of both sides and you're solving for x, you have to have a plus or minus. Okay? Oops. Not -3, plus or minus. That's what I meant. So plus or minus -9, which again is, we can split this up into the square root of 9 times -1, which is equal to the square root of 9 times the square root of -1, which equals, again, plus or minus. Oops, not there. Right? And so this, this square root of -1 is I. And so we just write this as plus or minus 3i. Okay? And I just stands for the imaginary number square root of -1. Okay? Because we can't take the square root of a negative number, right? If you do it in your calculator, you'll get an error. Okay? So in this case here, we're not going to worry about solving these. We just have to realize that, hey, these are imaginary solutions or imaginary roots. Okay? So again, we have 2 of them, plus or minus. Okay? And that's it. Have a great day.